Hello everyone, in this video I'll be explaining you the problem stone games. So this problem is exactly similar to the previous problem. Yesterday we had solved this predict the winner. So it's the same thing only, but only thing is here the length of the race given is 500. So yesterday it was length like just 200. So yeah, yesterday's problem could be solved using recursion only, but here we definitely need DP. So if you have not watched my yesterday's videos, I would suggest you guys to watch that video and come over this, because in yesterday's video I explained everything in detail. So here I'll be moving fast forward. So yesterday's problem, I mean, predict the winner. If you search in the Google predict the winner lead code, so you'll get you know the problem name. So let me just show you predict the winner lead code. So this was the problem yesterday's, and wherein the length was just 20. So but still yesterday I showed you like DP method as well. So yeah, let's start with the problem statement. Alice and Bob plays a game with a piles of stones. There are even number of piles arranged in a row. Okay. Each pile has a positive integer number of stones. Piles of I. Okay. So the objective of the game is to end with the most stone. The total number of stone across all the piles is odd. So there are no ties. Alice and Bob takes turn with Alice starting first. Each turn a player takes the entire pile of stone either from the beginning or from the end of the row. This continues until there are no more piles left, at which uh, point the person with the most stone wins. Assume Alice and Bob plays optimally. Return true if Alice wins the game or false otherwise. So let's understand this problem. So the problem name is stone game. Stone game. It's a 877 problem. So in the question, what they've said is they have given a array. It is called as stones, and whose length is n. Length is n, and this n is even. Okay. As they said, like there are even number of piles arranged in a row. So we can assume array A as A1, A2, up to so on, AN minus 1, AN. Okay. So this whatever element we have, it is in a row, and all, if you consider all the elements, so we have length as even. And they've said if you sum all the elements a1 plus a2 up to so on, an minus 1 plus an, its sum is, let's say, sum, and this sum is odd. Okay. So a of I will have some number of elements, and if you consider all the elements and sum it, it is odd. Definitely, if it is odd and the length is even, if length is even and Alice, starts the game first. Alice starts the game first. So if there are, even elements, so both the players will have, even number of piles, which is Alice will have n by 2 piles of stone. Similarly, Bob will have n by 2 number of piles of stone. But in these piles of stone, since the sum is odd, so definitely one of the player will have more stone. player will have more stone. Okay, and there is no question of tie, meaning both the players have, let's say some by two stones. This is not the case. So, and in the question they've said, whatever stones you have as the array, it is similar to previous question only. So, Ali starting first, it will either choose from both the ends of the array. It will choose either A1 or it is going to choose AN. Okay. Once it chooses one of the element, that element is discarded, and from the remaining element, now Bob is going to choose the element, and Bob again, if it chooses, it chooses like either A2 or AN. So it's a same problem only, just the wordings are different, and yeah, the length is like here 500, which is you know more than 20. The previous question has length of 20. Now definitely what we are going to do, um, first we'll try to make a recursive solution. Since in the array uh, let's call left pointer here, right pointer here. Since the elements are chosen from both the ends, either ends, so definitely you can, whenever you choose, and you'll be moving left pointer ahead. If you choose left element, if you choose right element, you'll move right pointer towards the right hand side. So after doing these operations, there will be a point wherein we have one element, both left and right pointer will be pointing to the same element. And if it is pointing to the same element, which means this stone, if depending on the whose turn it is, uh, more specifically here the turn last element will be obviously chosen by Bob only, because there are even number of elements, even number of piles in an array. So definitely first Alice will be starting and Bob will be ending. So this element will always belong to Bob. Okay. So in the base case, we'll check if left is equals to right. So we have just one element, and definitely this element will be choosing by Bob. So we need to return 0, comma. Uh, Let me call array as nums, or we can say piles. Let me write piles only. Piles of left. Here the meaning is um, will have a helper function. Helper function will have both the indices left, right, and piles will be sending, and will be sending turn, basically if it is Alice turn or Bob turn, and the return of this will be pair of int comma int. So that's the reason we'll be returning pair. So this element always belongs to Bob. So this pile belongs to Bob. So Bob will have the entire stones in the pile, and here Alice will not have. So it will be 0. But in the previous question, we were returning based on the this turn variable. Since there the length of the array was not even, it could be even, it could be odd, but here it is even, so definitely at the end Bob's turn will be there. So this base case, and let's write recursive steps. We'll check if turn is true, which means it's Alice turn. More specifically, we can say Alice turn. If it is Alice turn, so we'll definitely choose two elements. We'll say left stone. Okay, it is going to call helper function. Since we are using I mean Alice is using stone from the left, so left pointer will move ahead, right will remain same, and this turn, whatever we have Alice turn, it will flip its value. If it is since it is true, it will flip to false, and we'll be passing this piles vector. Okay, once we you know found the number of stones of both Alice and Bob from the recursive function, at this present state, you will be adding the piles of stone in the L dot first, L stone dot first, because in the pair whatever we are returning, the first number of stone belongs to Alice, and the second one belongs to Bob. So since it's Bob's turn, so definitely we'll be adding this number of stones to the uh, sorry, if it is since it is Alice turn, definitely we'll be adding it to the Alice number of stones. Similarly, we'll do the right stone. Since we are choosing the elements from the right hand side and we will be moving left hand side after choosing, so it will be R minus 1 and not of Alice turn. Then we have piles, and in this R stone we'll be adding the piles of R. Basically this is this many number of stones we are choosing. We are doing choosing operation. We are choosing either from left or either from right. Okay, we will check if, since it is a Alice block, this entire block belongs to Alice, so both player are playing optimally, so Alice will not take care of what number of stones Bob has. He will only be concerned about his number of stones. He will try to make sure he is having more number of stones in order to win the game. So we will check L stone dot first. If it is greater than or equals to R stone dot first. Basically, when he have chosen the left stone and called the recursive function, so whatever stones he has collected, that we are checking with the right hand stone when he have chosen and called the recursive function. So whatever number of stones he has when he chooses the right stone at this present state. So if it is the case, then in your stones you will be adding L stone, else it will be R stone. Okay. So similar thing we'll be doing with, for the um, Bob as well. And at the end, you will be returning this stone. So this will be a recursive function. And for DP case, what we'll be doing, we'll be choosing the states. So here the changing variables are left, right, both are indices, and then this turn. It will be either true or false. So we'll maintain three states in DP and we'll solve it. So let's go to VS Code. Not we'll go to Leetcode and let's solve it. So we'll take first n as the pile size. We'll take stones, okay, and we'll call a helper function, and we'll pass both the ends 0 and n minus 1. Initially we'll pass true because always Alice will start first, and we'll pass this vector. Okay, so in this stone we'll have two values. Let me initialize here. Okay, we have left, we have right, we have Alice done. So if allegation is true, Alice will play. If allegation is false, Bob will play. Okay. So this function is going to return, pair of int comma int. The first value belongs to Alice. So in the question they've said if Alice has more number of options, then we need to return true. Else we need to return false. Okay. So this condition will take care of that thing. Now we'll write the base case. We'll have to check if left is equals to right. So since the number of piles are even, so Alice is starting first, definitely Bob will be ending. So here we need to return 0 comma piles of left. Okay, we'll check if it's Alice turn, then Alice will play optimally. If it is else, Bob will play optimally. So we'll take left stones and we'll call a helper function. So when you're choosing left stones, so it will be uh, L plus 1 will be moving pointer ahead, which means basically we have distracted that pile. Okay, and we'll flip the turn because now Bob has to play. So once we have got from the recursive function the stones, in these stones uh, Alice value, because it's a Alice block, will be adding the chosen element. Similarly, he may choose the right side number of right side pile. So when you've chosen right side pile, we'll move left side. I mean, one pointer will be moving left side because that element is those piles are that pile is distracted, destroyed. So here again will be, since it's choosing the right pile, it will be R. Now we need to check if when you've chosen the left stone, okay. So if choosing left stone makes him, optimal, so definitely the final uh, number of stones is gonna be left stone. Else is gonna be R stones. The same thing will do it for Bob as well. Only thing is here, since Bob's all the stones are stored in second, we'll make sure it is second, right? Yeah, and at the end, you need to return these stones. Everything looks good. Let's try to run it. Line number 41. Okay, sorry, my bad. It just piles. It is second, not false. It is being tilly because this was a test case wherein uh, the number of piles are very large, n is large, so that's the reason TLE was giving. And if we try to understand, let's go to analyzing time and space complexity. So here n at max is 500, right? So the array element will be a1, a2 up to so on, a 499, A500. So this element will be, either chosen by Alice or Bob. So definitely we have a two choice. Similarly, this element will be chosen by Alice or Bob. So it will go till, 500 times. So it's gonna be 2 to the power 500, right? And as we know, 2 to the power 10 into 50 we can do this thing, right? If we do this thing, it is correct. Now it will be 10 power 3. 2 to power 10 is like 10 power 3. So 10 power 50. It is 10 power 150. So it's a huge number. So definitely we will be getting time complexity because is way greater than 10 power 8. 10 power 8 is our TLE range. So we are getting TLE. So in order to optimize this, we'll be using three states. We'll be moving towards DP. We'll have to maintain state, and there will be definitely a repetitive computations. So once we have calculated once that repetitive state, when we have that answer, definitely we need to just return it back. So let's move towards DP now. So in DP, uh, since we have three variables as changing, we'll maintain 3D DP. And in the DP, we'll be storing pair of int comma int, both scores, Bob's number of stones and Alice's number of stone. Since this left can go from 0 to n minus 1, so we'll be taking n size. Similarly, R can go from 0 to n minus 1, so n minus 1 to 0, so we'll be choosing, n size. And this Alice turn is going to be true or false. So true means 1, false means 0. So only two states are required to maintain. And in both, pair of incoming will be initializing with minus 1 and will be passing TP. Let's pass TP over here. Let's write TP in all the functions. Now, when we are, passing, returning the stone, we'll have to store the DP state. So we are storing here. And before computing this, we'll have to check if this state is already visited. So we need to return this state. Let's try to run it. So it is getting, passed. Let's try to use this last test case and check. So this last test case is also passing. Let's try to submit it. So yeah, it got accepted. So in this way, you could have, easily solve the problem. So it's a DP problem only, and it is very similar to the yesterday's problem. So thank you guys for watching the video.